Okay, good evening everyone. Let's see if this works, and if it does work, then we can get going. Does it work? Okay, I can see that it should work. So, hello, welcome, and the new year, happy year everyone, and welcome back to my live streams. I guess last time we saw each other, or actually you saw me, I saw you on the chat. In December, like early December, right? Because from middle December I was away, visiting my family and relatives and friends, so yeah, no streams. So here we are, like, as the popular joke on the internet goes, like a decade later, and we are back to picoCTF, and this is what we are going to be doing today. We are going to be continue solving picoCTF challenges. We basically solved 57 challenges already, but I think there is like at least 23 more, maybe even more. So yeah, there's still stuff to do, and yeah, less time to do it in. Perfect. Today's moderator is going to be KrzaQ. You can see his nickname right here, right in the corner. And if you have any questions for me, you do have to ping KrzaQ on our YouTube chat, on our Discord, or if you are on our IRC, then you just have to write !Q and then the question, and I will get to see the question as well. So there's that. Perfect. Now let's go with, with a standard set of news, I guess. Let's see what we have. Okay, first of all, this is KrzaQ's website, dev.krzaq.cc. He has some fun stuff, even though it's now a decade old. I'm sorry, I'm going to be abusing this joke today. I apologize, I will show myself out. Yeah, so do check it out. He has some cool stuff there, and it's always worth looking at it. Then, yes, if you are in Germany or near Germany, or like actually near Bonn, I will be in Bonn at the University of Bonn in 31st of January, so that is in, what, 3 weeks or something like that. I will be giving a guest talk about, well, it will be basically my notes about what I've learned while I started doing electronics with relevance to computer security. It won't be any innovative research because I am yet too newbie basically to be able to do any research in electronics just yet, but there's quite a lot of amazing and interesting stuff which I want to share with the audience there basically. The lecture, from what I know, is going to be open, so yeah, more details will be on my blog, and again, it's in Bonn in Germany, so here we have it. Perfect. Then page out. If you send us an article already or some other question or query, you might have not gotten a reply yet. Well, you got an auto reply, I guess, from me or from some other person. We are still in the process of basically changing some stuff internally, which basically means I'm restructuring a little how we approach reviews. And at the end of January, we will basically go and start with the review process for the next issue, for the issue number 3. And the deadline, if you want to submit an article, the deadline is actually 20th of February. So you still have some time, not a lot of time, but yeah, like, and make this your New Year's resolution, like write an article for PageStout, because why not? There's absolutely no reason to not write an article for PageStout. And this is going to be the new cover, and there will also be a wallpaper. You know, we have wallpapers like this one, for example, with each issue, so the new cover is also going to have a wallpaper with it. Then, again, if you have any questions, you have to ping KrzaQ on YouTube, or you have to ping him on Discord, because he actually gives me the, copy-pastes me the questions. I see there's a discussion how's like KrzaQ, how do you read KrzaQ as KrzaQ and not KrzaQ or whatever? Yeah, that's Polish language. Basically, RZ, you read it as Z. So KRZ is KrzaQ. Yeah, it is not an easy language to learn, and not because of this sound. But like, yeah, like, you can try, but there are easier things to do in life. Perfect. So, now yes, when I was away, basically through the December, I was, well, on vacation, basically. So I wanted to play some old games, and in the end, I played Amber Star. It's from Talion, a company which is called Talion Software, I believe. It's a game from like early 90s, basically, and I never played it. I never played the next part, which was called Amber Moon, and then there was a spiritual successor, which was called Albion, and I did play Albion when I was young, so then, like, this year, I basically, last year, I learned that, hey, there were actually, like, prequels to this game, which I really liked, maybe I should play them, but in the end, it's like a mix of 2D and 3D, RPG, old school style. You know, you do not have free movement, you can just, like, turn by 90 degrees. Same as in Arcane Sector. And I kept getting lost because for some reason the designers decided that, hey, you know, the compass, which you could really use when navigating 3D environments, how about you get it in the middle of the game when it's, you know, most needed at the beginning of the game? So what I did, I decided to like that it was way too annoying to just play it, so if you follow me on Twitter, you probably saw this large thread when I started to learn Amiga OS and Motorola 64K CPUs to like write a map, like an application next to the emulator where I was playing on, which would show me where on the map am I, so I could stop getting lost. And actually it was a lot of fun. I learned a lot about Amiga OS, I learned some things about Motorola assembly, about how the loaders work there, how the API works there, and also how to script Win UAE, which is an Amiga emulator. And yeah, if you follow me on Twitter, you probably saw it. I did, in the end, manage to, to get this basically where I had a game here, and then this automap showed me basically that I'm here, and like here are some places where I can visit. The wonderful thing about doing this was that along the way, I could find a lot of information from other people who looked at this game, who looked at the internals of this game. And like, for example, the map which you see on the right was extracted and was available on GitHub. And it turned out like that pieces of maps, like it was missing parts of some maps, like this part was missing or this part was missing in some parts of the game. And like I filed a bug on GitHub that, hey, your maps actually don't have it, and the person fixed it in like 3 hours. So that was absolutely amazing. I also discovered a website which has been updated about Talion Software, the creators of this game, which has been updated for over 20 years, and it had like amazing information about the game, about like the company, and about everything. So it was great to, you know, just to have a glimpse of that community. Anyway, if you want to take a look at that tweet, I will give you a link. Here we go. And yeah, in the end, I didn't complete the game because it turned out to be way longer than I expected. I got to about half of it, and then other things basically preempted me. So yeah, maybe I will finish it someday. One of the things which preempted me was the CTF, which, as you know, is the last CTF of the year. It was quite important for our team, and as it turned out, our team was actually called the Drunk Sector, because when we looked at our profile, we saw this. We saw like our proper logo, we saw Dragon Sector, and we saw that Dragon Sector from Poland is affiliated with None and has 8 players. And it turned out that all the other teams, due to, like, I guess, some creative programming, saw this. They saw like this instead of our logo. The name was, which is kind of covered here. How do we? Yeah, perfect. The name was Drunk Sector, and Drunk Sector from Polska is affiliated with Soplica, which is, by the way, a vodka, I believe, thing, and has way too many drunken players, which was absolutely hilarious. I laughed like really hard when this was shown to me, and it turned out that we noticed it after like 40 hours into the competition. So yeah, there you have it, like trolling at, you know, at CTFs, that also happens. So that was a nice joke. I really had fun with it. In the end, I think we finished the CTF 3rd or 4th, which was fine for us because, and we can take a look actually. Yeah, we finished 3rd, which was fine for us. and because that meant we won the season. So on CTF time, our team Dragon Sector for the second year in the row and third year in the history of our team, we were the best rated team in, like, top rated team in the world on CTF time, which I'm super happy about, and I'm really proud of my team. And I also had some small contributions this year, not as many as I had when I was the captain of the team, but still I was able to play, like, for example, the CTF, contribute to the Dragon CTF. So yeah, I'm super happy about it. Balson was second from Taiwan, which is absolutely amazing. Like, these guys rock. PPP, you always expect PPP to be on the podium. I mean, they are always there. They are one of the best, if not the best team in the world, so they are always there. P4, surprisingly, because I expected them slightly higher. Yeah, but they were also fourth player, so at second team from Poland. Like, yeah, congratulations to our friends from PPP. Well done, well played, and let's hope for 2020 to be even better. Then Tokyo Westerners, 5th place, congratulations as well. Like, super strong team, the same as T-Deliverers, I'm sorry, T-Deliverers. I'm butchering the name. I cannot speak English, it turns out. Yeah, also another great team, well done. LCBC, in my opinion, one of the top teams in the world. They usually were around first, second place. This year they are 7th, still in the top 10, and still amazing. DCUA, same thing, another top team, 8th place, congratulations, well done. Perfect Blue is something, a team which I know less about. I didn't see them a lot in previous rankings, but like 9th place, that's absolutely amazing. And Bushwhackers is also well known, a pretty established team, a really good one. So yeah, the top 10 isn't really surprising, I would say. And there are, like, if you go through the rest of ranking, there are a lot of other amazing, super strong teams. So I would say it was super, like, the season altogether was super hard and super challenging. And yeah, there you have it. So the first CTF is going to be, I guess, Insomnia. Well, the first ones have already been kinda played, like the Bamboo Fox CTF. And but it wasn't ranked. I believe it had like a rank of 0. Yeah. So then there was another CTF. I think, I'm not sure about the Grand Prix. Yeah, it also had a rating weight of 0. I think the first ranked CTF is actually going to be the Insomnia teaser, which is quite important for our team. While this isn't a qualifier, it is a teaser. The top 3 teams get like some hotels in Geneva, for the real CTF, which is one of the biggest, if not the biggest CTF events in the world. And this, well, totally in Europe. It's basically like 400 people playing CTF in one place after the Insomnia conference. It happens usually at the end of March, and we hope to be there again. We have been there for several years with pretty decent results, so we hope to go there. So yeah, there you have the start of the season. We still have a couple of days left, 10 days left to get there. So that's a quick update on what I was up to, and I guess I'm going to take a quick look if we have some questions, and then we are going to jump into picoCTF and continue solving the challenges. Okay, how to show the questions. Let's see if this works. You should see the questions here. This is actually a bug. The question isn't from Foxbridge. Foxbridge is actually just our bot, well, made by Fox for Charlie, which conveys messages from Discord to IRC and from the other way around as well, I think. Anyway, I have a good suggestion. Tell me if you like it or not. Maybe you should make a separate channel on the Discord server for crackmes, where people submit their crackmes and we publish our solutions, and after a couple of days the author releases the sources. Good practice. That is an excellent idea. So who is the question from, actually? Let me think. It should be on from Zero. Perfect. Yeah, that's an excellent solution. I think we should do it. Let me note it and let's make it happen, because it is an excellent idea. How do we make sure it happens? Let me put it here. Okay. Next question. Did the name change happen only to Dragon Sector? From what I've heard, no. There were other teams who also got affected I didn't see though, I didn't notice, so yeah, I just heard rumors that a couple of other teams also had some funny changes in the names and the logos and so on. Daniel asks, how do I make the jump from entry-level CTFs to proper CTFs? I find it overwhelming, but really want to improve. I think like the best advice I can give you is either join a team which is already playing. I wouldn't use the word proper. Let's call them like high-ranked CTFs, right? Because like on CTF Time we have rankings, and because like even the CTFs without any rate, any rank are proper CTFs, right? So yeah, join a team or like find people to play with and create a team, because in the end, the high-ranked CTFs are team-based competitions. They do require multiple people to be on the team and to solve it. Oh, by the way, the CCC CTF was absolutely like demolished by Past10 team. They are absolutely amazing. They had like, if you took the score of the second place and the third place and added it together, Past10 had that amount of points. So they just rock. They are absolutely amazing. And they, I think, won like, I don't know, 3rd year in a row or something. So congratulations to them. They absolutely rock. Anyway, so I think that's the best thing I can tell you, Daniel. Apart from that, it's just a matter of practice and actually playing the CTFs and reading the write-ups after the CTF for challenges which you didn't solve, practicing that, and like continue, practice, play more, like do other stuff as well, like, you know, learn exploitation, learn vulnerability research, learn crypto, and apply the skills in the CTF. And I think that's about it. Yeah, in the end, you do need a good team to be able to be high. I mean, that's how it works, right? It is a competition. Do we have like a junior team, like Drunk Dragons Juniors? No, I do not believe we do. It is an interesting idea, but yeah, I mean, it's up to Valis and Redford in the end, because they are the current, you know, leaders of Dragon Sector. So send any suggestions like that their way. Sparky Parrot writes, any stream regarding DBI, like Intel Pin, Frida, you mentioned it in a lot of different streams. We might make one. I guess it would be time for me to finally learn it. I did play with it a little, but again, I usually like just written my own engines for that. They weren't like as super cool as Frida is, for example, which is basically a Python JavaScript instrumentation thingy for binaries, which is quite amazing. But yeah, there you have it. I think I have it already on my list. I'll think about it, but I do need to take a look at it before I can tell you anything about it, because at the end of the day, I know how that stuff works. I've created things like that, tools like that, several times. That's a normal thing to do, especially when you're beginning with reverse engineering. But I do not know the tools themselves, and I would have to learn them before we could chat about them. Okay, last question, and we jump into picoCTF. Hagenvale, I'm trying to exploit a machine running Redis. I have access to it, and I have access to its keys. From this, I think I need to get credentials. Any ideas? No ideas at all, because I have absolutely no idea about Redis. I apologize, I know I should know about it, but for some reason, I never played with Redis. I have absolutely zero idea about it. I just know it's a database, and this is the extent of my knowledge. So, yeah, sorry about that. I know the answer is disappointing, but yeah. Yeah, so with that being said, let's jump into Pico. And if there are any other questions, I will get to them later on. So I will answer the questions later as well. They are not going to be forgotten or missed. Let's see what we have here. We have 9,150 points, and we have 57 solves, 23 unsolved. Let's just filter by unsolved and see what we have there. Sorry. We have, we have another assembly. We can start with that, with assembly reverse engineering challenge. Let me just quickly find the directory where I had this. Okay, here we are. And it's called assem3. I do need to connect to the shell in a second. So basically, if you remember the other challenges like this, they work like that we got a piece of assembly usually, and they asked us to call the assembly with some parameters and tell them what to return. And what we did for the first one, we just like ran it. Like we recompiled it, we used asm loader, and we just ran it, and we took a look at what is the result. And that's it. For another one, to use a different approach, because this is an educational stream at the end of the day, what I did is basically I showed you how to reverse engineer it in a proper way, and here I'm just going to take a look at it, and then we are going to decide what to do with it. Okay, the submission is not in the normal flag format, so it might be something else. I will have to connect to the shell later, but this is not required for this task. So let's take a look at the code. The code seems to be a disassembly, like in a form of, I don't know what shows this form. Is it GDB or is it object dump maybe? It's quite short actually, and I think what we are going to do is absolutely short. It's super short. It's probably 32-bit assembly. Yeah. So the funny thing, okay, what I see here is I see a lot of trivial stuff. First of all, this is the prologue of a function, which is usually at the beginning. This is nothing special. We can safely ignore it. We see some epilogue. Epilogue actually starts here. We can also ignore it, which means we have to focus basically on this part. We can also ignore the knob. I wonder why the knob is here at all, which is quite interesting actually. But there doesn't seem to be any weird shenanigans happening here. Now, only AX register is actually being used, is being zeroed here. Then this is actually reading bytes from the arguments. So we have the arguments on the stack, right? And this is reading arguments from the stack. EBP, as we can see here, is pointing to the ESP. ESP is the stack pointer, so EBP is now pointing to the stack as well. So this is reading from the arguments. This is pretty standard. And the only weird thing here are the offsets, I would say, and that it does a byte read and then it does a word read. So yeah, and then I guess we have to just do these operations. I'm going to solve this by actually translating this code quite quickly into Python code, because I think that's the fastest way to do it. So, okay, let's do a split. Oh, sorry, let's make the code a little bit bigger so you can see it as well. And I'm going to do this, and I'm going to create a test.py file. I am using Python 3, by the way. This is not what's supposed to happen. Okay, perfect. Now what I also need is I need actually the parameters. So this is what's going to be on the stack, right? So I'm going to import pack from struct and pack these because we do have to encode these into little endian. I actually need to unpack as well, by the way. And like to make it a little bit easier for us, a little bit quicker for us. So the stack is going to be actually a byte array. I guess it's going, it's going to be a byte array, but before we do that, let's create a function just called dd. And it takes a v and returns, it basically takes a value, a number, and it encodes it as bytes, as little endian, which basically means it does a pack of, and to get it correctly, yeah, this kind of pack, yeah, and it basically returns just 4 bytes. In little endian, this, this little thing here says little endian, like little part, like the slim part of the arrow is on the left, where are the low bytes basically, and the big bytes are on the right, as this triangle bracket indicates. Cool, so what we do is we do dd of this. Now the question is the order on the stack. The order on the stack will be like this. Let me turn on word wrapping. Plus dd. dd will return a string. So it's actually Python 3, so it will return a byte. It will return bytes. And now I can basically do a byte array out of it. But before I do a byte array, I'm also going to take a look what is else on the stack, because these are the parameters, right? And the parameters are already on the stack when we enter the function. When we call the function, which means the return address is also on the stack, so there will be some return address. We do not care, I'm just going to put a 0, this is going to be our return address. And then we push EBP, so we also, like, again, doesn't matter, but it is on the stack. And thanks to doing that, I will have, like, I can use these indexes directly without any recalculation. So, yeah, and let's do a byte array out of this. Cool, and now we can actually, like, play with it. Now, the problem is that I do not believe we are... Yeah, we will be returning EAX, by the way. So I'm just going to use this register, but I'm looking if we are using any high parts of a register. This is a Shift L AX, which is quite weird because this is a 16-bit register. Why would you shift it left by 10? But basically 0 is the register, so that's pretty weird, but okay. Now, you probably know, like if you know assembly, you probably know that AX is actually split into like an unnamed 16-bit upper part, and the lower 16-bit part is called AX, and then the AX itself is split into the higher 8-bit, which is A high, and then A low as the bottom 8-bit register. So again, AL is basically like bottom 8 bits of AAX. So this here, we have to remember that this, and this are the same register. It's the same register, just different portions of that register. Cool. And then what we can do here is, yeah, again, this is quite weird because it is zeroing the register. Like, it is a 16-bit register. We do a shift left by 16. I wonder what, because there might be two things here. Either the zeros the register or it doesn't change the value. And we can try both ways. So I think it should zero the register, but whatever. Cool. So let's start with this byte from this index, which is stack index 9. We put it in AH, which is again like the... it's not the bottom byte, it's the next byte to it. So we have to shift it by 8. Then here we do shift the AX. So we take EAX and we grab the bottom 16 bits of it. And this is how you grab the bottom 16 bit of something. And then you have to shift it by 10, which we are going to do. But then we have to store it again as a 16-bit register because we do not actually write everything in AAX. We write it in AX again. It is written back into AX, and AX is only a 16-bit register, so we do have to grab the 16-bit of the result, and that is what is going to be written. I'm actually going to do like this, like AX, because the top part isn't used anyway. Then we have, we subtract from AL, which is the bottom part of it, so let's grab the bottom part of it. And this is going to be actually funny because I'm actually going to do it like this, like in 2 steps. I'm going to first calculate the bottom part. We grab the bottom bit, the bottom byte of it. And then we subtract from it whatever is on this index, on the index D. So stack this index. If we are addressing, like using this notation, we are grabbing 1 byte. This is important because here we are then grabbing a word, which is important. And then after we do the subtraction, we actually again have to take only the bottom 8 bits of the result. And this is the AL, but now we have to incorporate it into AX. And it fully replaces the bottom 8 bit of AX, which means AX is now equal to, we grab the top part of AX, top byte of RX. So yeah, we mask out the bottom bits will be zeroed. And then we OR it with AL with the result of whatever is here. So we basically, like if we have the current AX, this is the current AX, it has 2 bytes, it has AL and HL. We zero this part, so this part is 0. And then we slide using the OR operation, the AL here. So there we have it. And AX is here unchanged, and this is the new AL, which is put here. Then we do the same trickery basically with the top part, but before we do that we need to get the top byte, And to get the top byte, you actually have to do two things. You first have to shift it by 8 bytes. You get the top byte and you shift it to be on the position of the bottom byte, and then you just mask out everything else and you grab the bottom 8 bits, the bottom byte. So this is how we get AH. And to AH, we do need to add whatever is at that index, so that would be stack OE. I'm not super positive I got, by the way, the indexes right, but this is something I have in my mind to check. If I fail with getting the solution, I should check the indexes. So I'm keeping it in mind, I'm not double checking it now. And obviously I need to, again, grab, the result might be larger because this is Python, so I'm going to just grab the bottom 8 bits of the result. And now at the end of the day, we need to incorporate it still. So to incorporate it, we basically do the same, but we this time mask out the the top byte, and we mask in the, like, whatever is on the bottom byte because we do not wish to change it. And we grab AH. However, we have it on the position of the bottom byte right now, so we do have to shift it by 8. So it's shifted into the position, or actually like shifted into the position of the top byte of that 16-bit register. And it's shifted in, so it's fine now. And then at the end of the day, we do an XOR. And we can do an XOR like this, because XOR doesn't never adds any bytes at the top positions. It's basically like only changes the bytes which it is like masked with, basically, well, or XORed with. So you can do this. We do not have to do this kind of stuff or this kind of stuff with XOR. It's fine because it will never add new bits to our value, which is like 16-bit value. And we have to grab a word, so I'm actually going to do another function which is going to be called RW, which is read word. And then let's say I want to, now let's just like, I get the data here, so like and what I need to return is I need to return an unpacked little endian. H is for unsigned integer 16 bits. From D, I'm going to assume D is the proper size, and this actually returns a tuple, so I need to grab the first element of the tuple, the first one, because there's only one formatting tag here. And when having this, what I do is I grab the stack, and I need 2 bytes from the stack, so that would be byte this and the next one. I'm actually, in Python, you obviously add 1 to the final index. So this will get us byte number 13, byte number 12 and 13, and it ends at 14. It doesn't get the 14. And I think that's about it. We can print the AX register here. So I'm going to print it. Do they say what kind of format do we need to submit? Submit the flag as a hexadecimal value starting with OX. So let's print it as such. I don't know if they want it to be 0 padded, but maybe that doesn't matter. I am going to 0 pad it to 4 digits. And yeah, let's do it. I do not need a semicolon here. So let's launch a console. I'm actually going to I guess I'm going to launch a Linux console. So let's use this one. Python 3 test, and let's see what we get. We got from import, obviously. It probably already told me that on chat. From extract, yeah, don't ask. I don't know what language I was programming today to make these sorts of mistakes. So this is supposed to be the answer. Let's see if it's actually the answer, because as I said, I might have gotten this interpreted it incorrectly. It's either does 0 or it doesn't change the register at all. And I think it should actually 0 it, but yeah, let's see. And yeah, this is correct. I actually got it correct. So it does 0 the register, which is fine. And yeah, that's a way to solve it. Obviously, a faster way would be to recompile it and just run it. But this is the way I would use for like larger CTF tasks, because it's the reason why you actually transcribe it, even though it's slower, is because if you make a mistake while doing, I don't know, like mental math or whatever, like calculating this on a calculator, it's like if you made a mistake, you have to redo everything. And here, if I made a mistake, I can just like fix it, like change this one character and rerun it, and that's it. So it's way faster to iterate if you have this written down. And yeah, like a random CTF tip. Perfect. So that one is done. Now, are there any questions to it, or are there any other questions? I am going to take a look on the chat. Or actually at the list of the questions. Again, if you have any questions, you have to ping KrzaQ, because KrzaQ is going to take the question and going to put it in our list of questions. So let's see. XOS writes, my question is, I'm doing some binary exploitation, sometimes my exploit just fails and I don't know my logic is right and I can't debug it. Why can't you debug it? Like usually you can debug almost anything which you are exploiting. And if you can't, and if it's non-trivial, you should aim at making an environment where you can debug it. Sometimes this requires a lot of work. Sometimes I'm not kidding. Like for example, sometimes you have to instrument an emulator to and add some like printing or debugging functionality there to be able to debug something. But at the end of the day, it is actually worth it. So yeah, binary instrumentation is okay for debugging, but I think it's a little better for actually like a recon phase when you're getting to learn something, or if you're like straightforward, like just changing the behavior of it. Okay, how many members from Dragon Software usually play in top CTFs, such as Google CTF calls or Hitcom CTF? Good question. I would say 8. I'm probably wrong by a couple of people, but let's say on average 8. Yeah. Okay, NixOS continues. Like today, putting the shellcode between knobs made it work, but putting the shellcode at the end before the red and the knobs in the beginning didn't work. Yeah, exploitation is a tricky business. So that may happen because there is like a lot of things interacting. Usually you might like find that some random instruction is suddenly overwriting part of your shellcode. Or like another thread suddenly like wakes up and says like, hey, let's just butcher this piece of assembly which I stumbled on the stack for like whatever totally unrelated reason. So it is, yeah, that's exploitation is like that. Like with experience, you basically learn some tricks which you can use to when writing something or debugging something to make it a little bit faster. But in the end, it is painful. You have to spend a lot of time, and that's normal. Will the talks from Pwning 2019 be published publicly in video format either? I thought they were already public. Let me take a quick look. They are supposed to be published pretty soon, I think, because I already saw them like being prepared. Okay. Okay, looking for Pwning probably isn't the best idea. Oh, here we are. Videos. No, I don't think it's published yet. Yeah, but they will be published. And pretty soon, I'm pretty sure. Because again, they were already made and like the videos were already prepared, so. Sparky Parrot writes, you mentioned preference for Python 2.7, and yes, but I did switch to Python 3. And I did learn some stuff which to make it easier to use Python 3 for the purposes I used Python 2.7, so now I'm fine with Python 3. Anyway, to read the question to the end. With the end of support 1st January 2020, it will get out of fashion. The current joke is that it's illegal to use Python 2.7, so you might go to prison for that. Which isn't true, obviously. And probably will disappear at some point. Are we going to survive? Yeah, we are. I mean, things come and go, right? The only constant thing in life is change, as the old saying goes. So, And again, I did switch to Python 3. I am okay with using Python 3 even at CTFs, so I guess if I could do it, you can do it easily. Okay, so Viejo says that I didn't forget about that. Okay, so what Viejo says is basically that what I forgot about is that SHL, let me open the task again. This one will zero the register, but it will also set a flag. And the flag influences sub. I did not forget about the flags. They just don't influence sub. Like, sub is not influenced by any flags. You might be thinking about the SBB instruction, which is, I did forget to switch. Yeah, again, here. Yeah, and this is a sub instruction, and there is a SBB instruction, which is subtract with borrow, and that instruction would be influenced by the flags. I don't think, however, SHL says the right flags. Maybe it does. Anyway, yeah, it probably does. So yeah, sub itself is not going to be affected by it. Like, sub doesn't care about the flags, basically. So yeah, you didn't catch me. But it is a good remark. You have to, when looking at code like that, you have to be mindful that apart from the registers, which you see in the code, there will be flags. So this is a really good remark. There will be flags there, which might influence an instruction. In this case, they didn't. In another task, which we'll be solving later on, maybe it will. Cool. Okay, then we will not go for the leapfrog yet. We'll look at the forensic one. Because we did look at assembly now, so let's look at something which is different. Revisit the last transmission. We think this transmission contains a hidden message. There are also some clues. You can also find the files here. Okay, so let's look at the transmission, which is a WAV file. Then we have some clues. Let's take a look at the clues. And I wonder if this is a forensic challenge or this is a steganography challenge. What is this? Moonwalk 2. Last time it was pretty painful to solve, right? But it was SSTV, like slow scan TV thingy. It's still downloading. Why is it still downloading? Okay. So let's play it. So I'm going to play it, but on my speaker, so you actually might not hear it. Or actually, I'm going to play it for you as well. So how do I do it? Oh, perfect. Or am I? There I am. This is going to be complicated. Okay. Okay. You probably want to lower the volume for a second. Lower the volume, folks, a little bit, because I have no idea how loud these files are. And yeah, so here we go. I actually will not be hearing the file, so I'm going to play the message. This is the message file. Okay, now I'm going to play it for myself. Yeah, it again sounds kind of like a slow scan TV. Then clue number 1. Okay, I'm going to play it for myself. Yeah, that's weird. Clue number 2. Oh, sorry about that. Okay. Oh, you can hear my speakers. If you can hear my speakers, then maybe it's better that I don't play it on full volume for you, so I'm just going to play the third one from my speakers. Okay. everything sounds like a slow scan TV, I would say. And yeah, last time it was painful because the audio source which I use, like for some reason the applications which I used for slow scan TV couldn't just accept a file and like read from the file. They had to have it played for them. And yeah, you know what, I'm maybe going to actually leave this for next week, and next week I'm going to have a better setup for dealing with audio files. I think that's going to be a better than trying to painfully solve it today again. So let's just skip it this time and let's look at it next week, and let's continue with some other challenge. Mini RSA, let's just go with mini RSA. Sorry to skip a challenge, but we will get to it next week. Okay, so mini RSA in that case. Mini RSA, let's decrypt this versus ciphertext. Something seems a bit small and the ciphertext is like this. Actually, let's do, yeah. We have the N, we have the E, and we have the ciphertext. So yeah, this is will be quite easy to solve probably. The problem is that if the ciphertext is it's smaller basically than N, and E is rather, sorry, if the message is short and E is small, then you can just do a square, not a square root, a root on the message, and you will get the result. The reason is because for encryption, you basically do kinda sorta, you like grab the message, M is the message, and you get it to the power of E, and it's actually done, everything is done modulo N, give or take, right? And if this is small, then like the result might actually be smaller than N, and that means the modulo operation will not be in effect, because for the modulo operation to be in effect, the result needs to be larger than the modulo is. If it's not, then you get like the ciphertext actually is just this. So this is the ciphertext, right? Because the modulo is not in effect. And if this is the ciphertext, that means, well, N, and which is, you know, the private key basically, right? It's not important. It's not in the equation. So, which means we can just do basically, we can grab M and we can do root of E, and we will get, we'll grab the C, this encrypted message, and we can get the M. And that's the whole idea here. So let's do it in Python, obviously. So I'm going to grab this. By the way, you can learn about this while reading Wikipedia, and Wikipedia has a really nice list of all the attacks on incorrect RSA implementation, because this is an incorrect RSA implementation which allowed E to be small, too small, and it's also a pretty standard thing on a CTF. This is a standard CTF challenge, especially on entry-level CTFs. There is bound to be one of the tasks which uses a small exponent. Cool, so Python, I'm going to create a.py file. Here we are, and now I'm just going to do like pov and 1/3. This might not give me a correct result, by the way, because it might do, this is, I think what's going to happen here is going to be, it will change it to a double, and we'll lose some precision, but it still might be fine. If it's not fine, we will find some root implementation which works on integers, and that will be better. Or we can code one ourselves if we care about it. I could actually show you how to do it if you're interested, but let's like see if this maybe works. Cool, so if we want to do it, we basically have to, let's actually go with a Linux console again. Python APY is 1, and, because we need Python 3. Okay, yeah, so basically what we need to do, and we might be losing some precision, is we need to convert it into an integer, and then we need to convert it into hexadecimal, and then we need to do the standard, well, I think this is fine in Python 3. Let's see, print b. This basically just removes the OX from the beginning. Yeah, we are losing a lot of precision here. Like, this shouldn't be zeros. These are zeros only because of the double conversion. So, yeah, we can still try to decode it. To decode it in Python 3, you do it differently. You do it p equals bytes from hex b, like this. Okay, yeah, it says picoC, and this is where the precision ends. So we do have to actually use something which a root implementation which is done on integers. I see you are suggesting, and by you I mean disconnected, to use, let's see if I have GMPI. Let's try GMPI2. And there's a function which is called, let's see if I have it. I have it. So there's a function which is called iRoot, and we can take it. So Mr. says to multiply it by 2 to the square of something to keep it decimal. No, that won't work, because it's not a problem, but is the problem here, but it gets converted to a double. And oh, unless you mean, no, but I don't think that will work that way. Anyway, the precision here is the problem, not really, but it's going to, you know, like fractional values. So okay, let's see what happens if we do GMPY of iRoot. Of A and 3. Okay, well, something happened. I have absolutely no idea what we got, but something happened. That's good. So I guess like the first one looks like a result, so I'm going to call it A, and then we have true, which I do not care about. How do we get, like, can we just, like, I don't know, like do int A? Does it work? Hey, it works. That's perfect. And yeah, we do again hex of A, and we remove OX from the beginning, and then we on this do bytes from hex. We would use decode hex in Python 2.7, but here we use byte from hex. And yeah, and this is need a larger E. This is the flag. Thank you, Disconnected, for telling me about the function that saved us some time. That being said, I can quickly tell you how would you do it if you would have to implement it yourself. Because basically what we have, right, what we need to calculate is that message is equal to, or rather, ciphertext is equal to message to the power of E, right? So what you would want to do, and we by the way have E and we have C, so we have this one and we have this one. M is unknown. This is what we want to find. And basically what you would do is you would try to find the, like, think of a chart, right? And they probably taught you at school to do, like, when there is a function, then this is called as a zero place of a function. At least in Polish it was called a zero place of a function. Like, this is a zero place, this is a zero place, and so on. This is obviously like a polynomial function. It's not a function like this, because this function would be different. Anyway, if you'd find the zero place of this function, so you'd find the place where this part is equal to 0, so you would find one of these places, then you basically get the solution to the equation. And to do that, you use a bisection. So this function would be more like, I don't know, what would it look like? Let's say it's like, a function looks like this, because why not? And you start putting different numbers instead of m here. I don't know, you start like with 1000. 1000 is too small, it's way too small, but it's fine, whatever. You start with whatever, and it would be like somewhere, for example, it would be way too small, so it would be somewhere here. And given that is larger than 0, you know that you need a number which is, in this case, would be larger. If it's larger than 0, you need a number which is larger. So you multiply the number by 2, for example, right? and then you would start approaching 0, and then you would suddenly go negative. So you know that your number is now too large, you have to make it a little bit smaller, and using bisection you would in the end arrive at this point, and this is your root of the number. This is the simplest way to calculate it. What is going on in the CPUs is they use a better method than this, but there you have it. So if you know bisection, you can. If bisection is exactly the thing which you use in blind SQL injections, by the way. If you know that, you can solve this equation in a programmatic way, so which means you can actually implement this function quite easily. Yeah, so that's this task, and which was rather easy if you knew that there is this bug in RSA. If I wouldn't know about that, what I would have to do is I would have to start looking on Wikipedia, for example, and try to figure out like what might be the problem here. Okay, are there any questions? Show the questions, and let's look at the questions. You will see the questions here. Again, if you have any questions, you have to ping our moderator, KrzaQ. So Simon writes, why you are not using IDE for Python? I am in general not really using any IDEs. It's a personal preference. If you like IDEs, that's fine. I just am using Sublime and command line, and that's enough for me. It's, again, a personal preference. If you prefer IDEs, that's absolutely fine. I just prefer editors which are like turning on instantly. You might have other preferences. So that's the reason, like personal preference. Could we use Wolfram Alpha? Yeah, we could use Wolfram Alpha. If you don't know, it is basically this website which is quite powerful with different mathematics stuff. And like not only mathematics, by the way. And we could maybe put that number there and use it to calculate. We can actually try, like let's try it. That's a good suggestion. So Wolfram Alpha. I think it's actually like, website is one thing, but they do have the software. I think, is this the company which makes Mathematica? I don't remember. Anyway, so what do we want to do? We want to basically grab the number which you do not see on the screen. I want this number, and I want to grab like a raise it to the power of 1 by 3. And let's see if it actually is able to. No, wait, where's my big number? Why did my big number not work? Let's use a different notation. Let's use an arrow. So, oh yeah, by the way, yeah, we use like usually mark the power operation as a caret. This is how the char is called, is a caret. This actually is from like the old basic languages used an arrow, an up arrow for a power operator, because on older computers you could actually quite easily make an up arrow character. Currently you have to like remap your keyboard to do that. But like the new keyboards afterwards didn't have an up arrow, but they had this character, so that's why the power is suddenly marked with this character. So let's see if that works. No, it doesn't. I guess it doesn't like this like large number. Or maybe it wants like, yeah, we can, I do have actually like arrows here. Let's see if it understands an arrow. No, it doesn't. Whatever. I'm pretty sure there's a way to do it. But yeah, this isn't solving Wolfram Alpha, this is picoCTF. Okay. Oh, so the 0 point or 0 place, KrzaQ says that in English it's called the root. It's a root of a function. I didn't know that, thank you. Joe says, just on putting CTF Wargames experience on CV. Thoughts on putting CTF Wargames experience on CV if you lack industry experience. Even if you have industry experience, I would put it in the resume. Yeah, totally. Like especially if you have some, like something, you know, like you're a captain of a team, for example, that is a good thing to put on a resume because that exhibits your leadership, your actual leadership skills, right? And organizational management skills, which is a good thing to showcase in a resume. if your team got like top places somewhere, or like is in top 100 of CTF times, like totally include in the resume as well. If you organize the CTF, totally add it as well. So yeah, and people do it, people do add it. So so it's nothing weird. It's absolutely normal to put CTFs on the resume, and I saw it on a lot of CVs, and I have it on my CV as well. Oh, this is a great remark from Gaps, that in mini RSA it's also because of a lack of padding. Yes, that is absolutely true. Usually in RSA you want to grab your message and you want to pad it before actually rising to the power of E, and then after decoding you remove the padding. This is how normally you use RSA. So this is a great remark, thank you for adding it. That's true. KrzaQ says that in the Wolfram Alpha I should use the power as well. Let's check it. Why not? So let's open it again. And instead of doing this weird stuff which I was trying to do here, we are going to use POV and 1/3. Same like in Python. Yeah. Okay. What's your opinion on languages like Zig or J? I absolutely have no idea. I never heard even of these languages, so I do not have an opinion on them. Let's take a quick look. What are these languages? Okay, it's strongly typed. Okay, show me code. Okay, I have no idea what is it, but yeah, I have no idea. So I would have to look at it, write some code in it to have an opinion. I guess it's not really a popular language, otherwise I would probably have heard of it before. So yeah, no opinion. Cool. I think we can go after the next challenge. General skills, music. I wrote you a song, put the in front of the flag. Cool, let's go with music. It's general skills, so I expect it to be... All the challenges from general skills until now were rather easy. Okay. picoCTF, my mind is waiting. Okay, what's going on here? Do I have to read the lyrics? Let's read the lyrics. Put my mind of pico into this, my flag is not found. Put this in my flag, put my flag into pico. Shout pico, okay, my song's something. Put pico into this. Knock this down. Put this into CTF. This doesn't look like lyrics, this looks like an esoteric programming language. So, cool. Esoteric programming languages, lyrics. Rockstar. Okay, let's look at the examples. Okay. But it uses say and we have a shout, so I'm not sure if this is the right one. Maybe. Put your hope, okay, put this. Maybe, it might be Rockstar. Okay, now we need an interpreter. I might, by the way, be mistaking. I might be totally mistaking. This might be a different esoteric language. But, I mean, we do have to take it. How do we run it? There's an Rockstar to Python. Okay, do we have a, like, something which just... this one. Okay. Here we are. Hello. Perfect. Let's just copy paste this here. No. It doesn't like it. How far does it get actually? Line 34, so it gets actually pretty far. It goes up to here. What if I change this to this? Okay, what if I remove it? Does it actually work if I remove it? Output. Yeah, something is going on here. This is the output. What, can we change this output into something meaningful? Let me open. Okay, I said I'm using Python 3, so let's just use Python 3. Let's just put it here. Split it, and let's just like change it to an integer and x, and actually change it to the character for x in this thing. Rock. Are we guessing the flag? If we are guessing the flag, I'm guessing it's going to be Rockstar with 3 R's at the beginning. Let's get the flag. picoCTF Rockstar. It's incorrect, so I guess this is not. No. Or maybe this. No. Okay, so we are back to actually trying to. We know this is we know we are in the right neighborhood basically, because rock makes a lot of sense. So we just need to either fix the code, or we need to. Let's maybe continue this and see. Okay. Okay, that absolutely failed. Okay, and let's run it again. If x, okay. Rock and r. Okay, let's guess the flag again. Rock and roll. Incorrect. Okay. So it's something else. And let's just copy paste everything. Fix this again. And it doesn't like. Please compile it. Or you're not compiling it. Okay, security is important. It doesn't like this line. Why doesn't it look like? Is important something which was not defined? Important is here, but we do not have important. Let's just like comment this out. 43 is put security. Let's find a different implementation. Online. Perfect. I like online. It doesn't look online. Okay, let's find a transpiler. Something which is easy to run. If I tried the compiler on the official page, is there an online compiler? Is there an official page? There is an official page. Try it. Thank you, Daniel, for pointing me to this. This might save us some time. And it does save us some time. Perfect. Daniel, you are the true winner of this challenge. What? Oh, this is Linux. I was pressing F7 to get a menu of like last commands, but it's... well, okay, we couldn't guess it, I guess. Let's do join on it. Yeah, unguessable. It's a good CTF. And that's correct, that's all of it, so that's about it. I guess in this challenge the main thing was to guess that these aren't really lyrics, these are an esoteric programming language. And once you knew that, yeah, well, maybe never, I'm not sure about never, but I don't believe I played with Rockstar before that, so I think this is... And I might be mistaken here, in all honesty, I did play a lot of CTFs. But I think this is the first time I saw Rockstar. Anyway, what gave it away is like that put this into something, my flag is something, shout something, started to look more like a programming language and less like song lyrics, and this is what gave it away for me. This is why I was able to guess that this is an actual language. Yeah. It's a interesting challenge. It's kind of guessy, but I think it's guessable. It's kind of guessy, but guessable, so maybe it's fine. Are there any questions? Let's see. Show. Sammy writes, I was so happy to find your OSDev series until I found out it's not in English. I'm sorry about that. Will you make an updated series in English, please? Yeah, good question, maybe. Sorry, I'm looking at the chat. Oh. Anyway, sorry. So yeah, I'm currently not even updating the Polish version, basically. So I'm not sure about if I will be doing one in the English language. I might, but it's a far away might. So yeah, sorry, I wouldn't count on it. It's just that the problem with the OSDev is basically that it's either I have to do a lot of work apart from what I'm showing on the stream, and this is quite hard for me because of my schedule, basically. Like, if I would have more time, then yeah, totally I would, but yes, like, you know, with work and other stuff, this is basically will not work out. And yeah, and if I would not do additional work between the streams, it would be a stream of me reading documentation and like Googling for stuff which doesn't work. And that is not... I got like some negative comments about doing that on live streams, so I prefer not to do that. Yeah, that's basically it. Have I ever used burp suit on a CTF? I'm not going to say never, but I use Fiddler. Fiddler is super similar to burp suit. But, well, okay. It's not similar. It's a tool which is used for similar things, but the approach is different, and I prefer Fiddler. Burp is fine. There's also Zap, which is open source, which is similar to burp. And yeah, these are super useful tools on all pentests and all kind of stuff. And I would recommend learning one of these tools, whichever you prefer. Do you prefer Fiddler, or do you prefer burp, or do you prefer like Zap? Whatever works is fine. But you do have to learn one for web security challenges. Well, maybe with like the dev tools in modern browsers is not as important as it was years ago, but yeah. Okay, you do have to ping KrzaQ if you have any questions, by the way. So let's select the next challenge. You have a forensics packet capture. Yes, please, packet capture has to... Packet capture. No, it's not the proper way to say packet capture. Shark on wire 2. We found this packet capture. Recover the flag that was pilfered from the network. Pilfered. I didn't know this word. Is it a word? Is it a real word? You can also find the file here. Okay, let's download it. I really like pickups and I like network challenges, which is quite surprising because I by no means am a specialist with networking, but I do like pickup challenges. Shark on wire 2. Okay, let's open it in Wireshark. Funny story from ages ago related to the update window which you just saw. On KrzaQ back in the days, there were a lot of stories flying around of people having exploits prepared for Wireshark, so it is an attack defense CTF by the way, so people were running Wireshark to listen on the traffic which was coming into their machines which they were supposed to defend. And the rumor was that some teams had exploits for Wireshark prepared to either crash it or, you know, just spawn the machine of the defender. Yeah, a funny story. Okay, Blame says that he sent a link to the Rockstar interpreter 5 minutes ago. I did look at the chat, but I did not see it. So it turned out that yeah, YouTube chat does not like links for some reason, which is weird. I did disable all like automatic spam detection and like bad word filters and so on, because we have moderators on the chat all the time. We have either KrzaQ, Foxtrot, Disconnected, or maryush. So I have no need for automatic filters, right? But yeah, YouTube chat insists that links should like be held for review or just never sent to the channel, which is annoying. But there we have it. Okay, cool. So we have a pickup. The pickup is, by the way, the pickup is a super simple format. So you can just look at it from like whatever file viewer, and you can just string through it as well. So we can do. We can always grab to win, right? Always apply grab to win. So we do strings on the, or like string. Let's just grab pico -i or picoCTF even on it, on the capture pickup, and it says that matches. So let's do strings now, strings, and let's grab for pico -i pico, and we have some stuff. picoCTF sure is fun. I really want to find some picoCTF flags. I think they're having fun with people who would actually go after this method. So worth a try, unless this turns out to be a flag, and then I will be really like laughing at myself. So let's see what kind of, let's just, okay, you probably know Network Miner. I am going to run Network Miner for this challenge. And Network Miner is an application which basically does aggregating of the pickup information. So while Wireshark is for looking at individual packets, Network Miner looks at everything and tries to filter the information. So it looks like this. I'm pretty sure you saw it already. I'm going to just feed the pickup into it, and it's basically going to show me all the hosts which are here, then all the files, if any, were transmitted through FTP, HTTP, or whatnot. This is the free version, by the way, which you can download from the Network Miner site. It's really great for CTFs. Well, it's not always useful, but it's sometimes useful. Messages have nothing. Yeah, I guess we don't have. There are some anomalies. That's fine, and there are some machines. So this doesn't really tell me too much. Let's look for how many sent packets there are, or sent bytes actually. Which machines are the most chatty? And this machine, the second one, sent 7,000 bytes, but the top one actually sent 12,000, so that's not a huge difference. What's the difference between, like, for example, this IP7, the difference is there. So I would say let's focus on the one which has the this address. So I'm going to apply a filter. Oh, actually I'm going to, I guess, do this and tell it to, where is, oh, it's an IP address, not a TCP address. This is the source address, so I'm just going to filter it. Apply filter, select it. And here we have like everything from this thingy, from this host. There are some TCP sessions. Let's look at one of the TCP sessions and let's take a look what's there. So I'm looking at this part of the screen here. Is there something which looks, you know, weird? Or what is the... So it seems to be sending some stuff to an HTTP server, or an HTTP port actually. It's sending weird stuff to it. I'm going to click follow TCP stream here to get... This looks weird. Yeah, it doesn't look too interesting actually. How many streams are there? Let's take a look at this one. Now it's the same stream. It's quite weird because one side is just answering with this stuff and the other side is sending something that looks kind of encrypted. Let's show the data as a hex dump. I wonder what is this. And it's just replying with 8101. Maybe this is just like, just garbage and like, you know, a red herring, which is keeping my time away from other hosts on the network. So let's take a look what other stuff are on the network. Something interesting. There's a lot of like this UDP, IRP stuff going around. Why are there like a lot of A's here? That's pretty weird. Let's tell it to... let's actually like look at only this address. So filter by it. And UDP, as you can see, it only sends UDP with this AAAA. Okay, and maybe it's supposed to generate traffic. Okay, let's change the approach. In that case, we did see in the grep pico as a string. Where is the pico? Look for a string which is pico. And it's not case sensitive. Yeah, just pico. Find it. No packet contained that string in its info column. No, I want it to be packet bytes. Yeah. Okay, and now it found something in... There's a upico in user datagram. What kind of transmission is it? It's a UDP between something and something. And it says it's a malformed packet, by the way. Okay. It's quite interesting. Yeah, this is the same host. I'm wondering if this is, or is it the no. But it's UDP. Maybe we should focus on UDP. Let's do that. Let's focus on UDP. So let's apply selected. We applied the UDP filter. And we have some stuff here. There is like, this is DNS traffic. I do not care about DNS traffic, I think. So let me, and not mDNS. Do this. And now I'm going to, again, be looking here and I'm just going to tap down key to look at the packets. How are they changing? Okay, so there's a lot of noise. What is this? SSDP, so not NSDP, not SSDP. Okay, so I see a pattern. It's here. It's this number. Like, look at this character basically changing. It's like CTF, right? Where is it, by the way? It's like 1 is data. Okay, so yeah, it seems that some packets have a length of 1, and earlier we also saw length of 1 is like I C O, so that would be like pico probably. So can we find, like, apply a filter where actually we get a length of 1? Apply a filter, selected data length of 1. Okay, this is our filter. And now let's look. COCTF, CTF, then an curly bracket, as you can see here. NOT underscore, yeah, this looks like a flag. It's quite funny because it seems to be sending it to different hosts, right? Does it say not a flag? NOT underscore a flag. Okay. I'm wondering if this is only on the 13.13 host. Because there are several hosts, right? So let's look only at the and IPDST host is equal to, I don't know, let's say 10.00.12. IPDST host. What did I mess up here? Anyway, let's look here. ICOCTF STI. Yeah, that might be it. I'm going to open a notepad and just note it manually. So that's like picoCTF, we know this part, and what's inside actually, that's the important part. So let's make it smaller. F, and this is the opening bracket here, so the next packet is S. T. A, T, A, T. 3, 1, 3, 5. Sorry, there were two fives, there are two fives. That's an underscore. E, and a closing bracket. I'm not fully convinced this is a flag, but let's try it. That's incorrect. It's not the flag. So it might be a little bit more complicated then. Oh, because we are actually, so this and this are from, this is from a different host. I didn't notice that these addresses differ. There's always 222, and then this suddenly is changing. So let's remove these two. Let's try this one. It's not going to be the full flag. Yeah. Okay, I'm guessing it's going to be, like, the flag is going to be split between several streams, and at this point I'm somewhat getting annoyed by everything. So what I'm going to do is I'm going to just apply a filter. I want to probably go with length 1. Okay. And then what I want to do is I want to export it. So basically, give me a second. Yeah, okay, that's fine. So I want to do file, then export by the packet dissection as JSON. And I want to all packets, only displayed packets, which is already filtered. Packet summary line, include whatever, and yeah, we can grab packet bytes as displayed, all expanded. That's fine, and let's just dump it as JSON. This is how I usually, by the way, go about this. And now we can start to write a Python script. So we do have a JSON dumped. It looks like this. There is like a lot of stuff that's just loaded. It's 2 MB, almost 3 MB, but that's fine. That's not a problem. So import JSON with open asdf.json, read, I don't think it's supposed to be binary, whatever, as f, we'll find out soon enough. Data is JSON load f. Okay, let's see if this works. And Okay, Python 3D. Yes, here you go. It works, so it's fine. And now for packet in D, we need, this is one packet. It's a list of packets, right? We need to grab frame, so it's source. So A is P source of frame, I believe. No. Or is it UDP? Yeah, it's data raw. Is it? Yeah. It's data. Let's go for data. Let's see if we are getting it correct. No. Where is the data in? The data is in UDP. Okay. No UDP. Where is the UDP in? Is it in frame? I think it's in frame. It's not in frame. In layers frame. There's no UDP. Maybe it's just like okay, there's no data, so it's UDP. Okay, so it's UDP, and then oh, it's not UDP, it's just data. Yeah, it's just data. So the data, and we get data. Okay, cool. So let's do something simple. I guess let's just print the yeah, we get something. That's fine. So let's decode it. So bytes from hex A. Okay, let's just like convert it to string. It's fine, it's fine. And let's also extract from this the source address and the destination address. So like src and the DST. We need layers IP. Let's go upward. So this is IP layer. And we need length. No, what do we need? We now need source and destination. Yeah. So IP source. And IP destination, we can start correlating the data. Correlating. Yeah. Okay, cool. So now we can print source, destination, src, st, and s. Okay. Yeah. So that's interesting, isn't it? Because we have one. Oh, now I get it. Aren't we funny? So here's my guess. My guess is that either I think the destination is going to tell us what is the order. So like this is the 12 character 13, no, but it repeats here, so that's weird. Okay, we can, let's do something like this. Let's try to like do some magic. No, let's do it here. Let's sort it by IP, or like group it actually by IP source, I guess. So in this case, what we need to do is we need to, if source in IP source, then IP source of source plus s, otherwise IP of source is equal this. And then print IP source. Okay. So we have from the source 2 we get this thingy. Not stat data flag something. This looks promising, by the way. Then we have, let's just maybe do for kv and IP source items, print kv. Okay. Okay, so maybe it's like this. This is the beginning. This is the second thing. This is the third thing. Okay, now let's also try to do the same with destination. And let's do the same with destination. DST, 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 and DST. And let's also do the same with printed with destination. Daniel says that there is no way I'm going to solve this stupid task. Let's just do another print here. So we are now pits, yeah, right. Print. Let's just do this. Wait, what? No, okay, that's okay. What do we make of this? Not a flag. And then we have this staffing here. So let's for a second remove this and just look at UDP packets. We had this nice filter here, and let's take a look at the lengths again. And let's look at the traffic between these. So the data length is 1 here. What about like any traffic between these hosts, which is longer? Okay, this is like A, that doesn't make too much sense. I'm basically wondering if there are any hints somewhere about it. Or what might be interesting here? It's kind of a guessing game, right? Like, which part tells us what is the order? Is there a part which tells us, I don't know, is there like, for example, a MAC changing between the packets? No, the MAC stays the same, all the fields stay the same. Where is the timestamp here? Does the timestamp make sense, or is it like fictional? No, it does make sense, I would say. Can I follow a UDP stream? I don't know, but oh, I can follow. Yeah, that's cool. I don't know, but thank you to Gaps for mentioning it. I didn't know you could do it. Okay, so how about we look at TCP for a second? Is there anything interesting between these hosts happening in TCP? No, TCP has almost no traffic at all. And the traffic is rather weird anyway. It's just talking about the other things, so I would ignore the TCP traffic, I think. Is there any like no non-UDP, no like ICMP? Is there any ICMP traffic? There is no ICMP traffic. So maybe not UDP and not TCP. Are there any other protocols? There is a ARP protocol going on here. Yeah, these looks like pretty standard queries, I would say. Quite a lot of them, actually. Oh, there's another computer here. Okay, so let's look at all the packets. And now I'm going to manually look for the packets which are there next to anything important. Alright, what's this? This is like end. Why does it say end? Okay, what about like packets with a length of 5? But we can see that the source is changing. You know what? I'm going to do this, like sort by the source. So, oh, this is quite interesting. There are some sources with this like, yeah, like it says start here. Then there's BBB, that's weird. Are we looking at the wrong thing? 75, 78. Why are there so many IPs? No, look, I want you to look here for a second. Yeah, like the IPs are different, right? But the MAC stays the same. So this is the same machine which is sending as the source, setting as the source different IP addresses. Okay, and then we have some weird sources. This is fine. And then we have IPv6, which I think we can ignore IPv6. So my take on it is that we should probably look at these. Now, the interesting part here, right, is that like we have this end string here. Then we have a lot of this stuff. The interesting thing is that the last part is like of the IP, like 66 to 79. This looks like letter range, like ASCII letter range. So there's a lot of this traffic. Where is the traffic which is related to the 10 something something double digit? 24, for example. Okay, so I think we can go only with UDP again. Let's go only with UDP. No, this is not the right one. Here we go. No, sort by. Okay. So at the beginning, we have this 6 thingy which says pico. Then this says some stuff. Then there's 8 which says I really want to find the flag, and it repeats it several times. Then we have 1 which is CTF. Then we get 2 which has a lot of not interesting stuff in it. Maybe the order of the packets is just enough to solve it. Then 100 has a lot of A's, and then we get 2 to the STAT. Then, well, this is like another thing which shouldn't be here, and not LLM&R protocol, whatever that is. Yeah, we get underscore FLA. This is like not the flag, right? Thingy. No, stat A underscore FLA. Why didn't? Oh, because it's sending it to a different host. Okay. Then we get 24 to 25, which says, what is the data here? Okay, so this is F. But we can take a look here. It always sends F, and so is 25 always receiving F. There is nothing else here, nothing interesting. The same way like this one isn't interesting by any means. So we can just ignore it. We go here again, and we have this data. This is a malformed packet for some reason, fine. But where is the traffic which I found with like the double digit at the end of UDP packets? Is it at the end? Here we are. Start. Okay, so this is start. And this says end. And between this, okay. Yeah. I'm betting these are character codes. So let's go with that. Let's assume these are character codes. So where is my filtering script? Let's use the filtering script first for this. I'm going to Am I filtering by the data here? I'm not filtering by the data, right? So I should, why don't I have any IPs related to this? Because these are not sending any data? No, we are sending data. Oh, because I know, I exported not everything. I didn't export everything. Now I'm going to export everything. So export the section as JSON. Only the displayed, all the displayed packets, and all expanded, and yeah, let's not include this. Let's use this, save, yeah. Let's run it again. Not all of them have data. So let's do this, try. If it fails, like accept, key error, then whatever, like just like continue. Typing is hard. What changed? Let's continue here. What is it? I'm just going to comment this out for a second, like everything, I guess. And tell me, like, print A. What do you have at A? Why are you Python 3? Oh, yeah, that's fine. Here, like, A is A, replace the semicolon with nothing. Yeah, that's fine. So now let's take a look at this. Okay, there's a lot of garbage here, but that's fine. We do not care about this. What we care about is we care about the IP addresses. So let's make another one, like A is here. No, that's flag, maybe flag, I don't know, but maybe flag. And what we care about is whether the, how do we go about it? We care about the source address, right? The destination address, yeah, the destination address is whatever. So the source address is going to be, we are going to do x is equal to the source address split by a dot, and then we select the last one, and then we convert it into an integer. And if x is like not in the ASCII range, so x is what's the ASCII range? So 32x is larger than that, 127. If not this, then we do whatever. If this, we do flag. We add x as a character, and at the end we are going to do another print times 70 print flag, and let's see what we get. Anyway, that's not great. Thank you for the donation. I usually have a animation playing, but for some reason the animation is not playing, or did I miss it? Guided Hacking, thank you for the donation. The message says Gendbale is da man, and I got 10 pounds. Thank you, that's much appreciated. What happened with animations? I don't know. I need to debug my script later on. Again. Okay, so yeah, this doesn't look like a flag. It looks like it could be a flag, but it doesn't. It obviously isn't a flag. This looks like really a guessing challenge. Okay, well, again, we did have the start string, so back to the drawing board. We think again. We have the start here, and we got ace, ace, ace. Okay, the weird thing which is happening here is like the ports are super weird. So maybe let's take a look at the ports. Like for example, this is the start. Where's the start? This is the start. And it has a port of, we are looking at the UDP ports, obviously. So port, this one. It's 5000. And then 5097 and 99, 111, 84, 70, 123. Yeah, this is still ASCII range. So maybe this is what it's about. So this is, yeah, another idea, is that we can use actually this the same, but what we need here is we need the port. So the port is going to be P, like I'm just going to copy it. And the port is an UDP, obviously. So it's a UDP. How is the port field called? We do not need this anymore. Ethernet frame, IP frame, UDP port, as expected. No surprises here. Okay. And we make an integer out of it because it's a string. If the port is like larger than 5000, then let's do this. Port minus 5000. Let's see what happens. We get nothing? Why do we get nothing? That's weird. I'm going to, I guess, disable this printing for a while. Oh, because it's hexadecimal, obviously. Wait, if it's hexadecimal, then these values are... Oh no, wait, it's not hexadecimal. Or is it hexadecimal? The port isn't usually in... No, it's not hexa, it's decimal. So what is wrong with you? Why are you showing 8000 when it's obviously not 8000? Because your port is, you do... because... Oh, there are two ports. That's quite funny actually, like... two keys of the same name. I do need the source port. This is, by the way, something called... You can find bugs like this sometimes, like security bugs, when you have two keys of the same name. Like, for example, you are sending to a website a structure which actually has keys, and then the website is super large and has like different parsers for JSONs all around. One parser might actually select this ID and another, this value, and another parser might select this value. For example, one parser might always respect the first value, and another parser might always respect the last value. And due to this, for example, you might have some sanity checks going on the first value, and then the last value of the key is used. It's called HTTP parameter pollution, and it's a really amazing class of bugs. And yeah, I guess here we have like a naturally generated thing like that, because this shouldn't happen here. Anyways, I'm going to use the source code, source port, and well, close. We are getting close, I believe. picoCTF and something. Why do we have so many A's? Is there an answer to how to filter it? Can I just do like... let's do it like this. This is absolutely stupid what I'm going to do. I'm going to do replace A with absolutely nothing. Okay. I think we can safely assume that there was an A here. And let's copy it and let's see if this is actually the flag. This is not correct. I probably removed too many A's. That's probably the problem. So, okay, let's do it like this. Let's do this remove. And then just print the flag without the replace and see if we can figure it out. And maybe it's data. Oh, via, maybe it's via. If that's not the flag, then I'm going to take a look at the packet again. No. Data maybe? Yes, that's correct. Guessing the flag, the best way ever. Cool. So, yeah, that was... I'm tempted to say it was a guessing challenge, but I might have not understood the challenge as the author intended the challenge to be understood. There were a couple of red herrings, as we saw, and the red herrings like sidetracked me for multiple minutes, so that's weird. Anyway, I think that's actually it. So we did solve it in the end, and yeah, it was steganography by all means. I'm not super happy about how exactly that steganography worked, but maybe there actually is an easy way to filter out the A's, but whatever, we got the flag, but what matters. It's a weird task. It's not a type of pickup tasks I like. I prefer where you have to analyze the real protocol and extract data from it, not where you have to basically figure out where the data is hidden, because that's kind of data steganography. It's something, yeah. Anyway, I'm going to answer some questions and we are going to finish for today. Let's take a look. We solved a couple of more challenges. So we had 33 unsolved challenges last time, and still we have 33 unsolved challenges. We solved, what, 3-4 challenges, and we still have 23. I have no idea how it works. I guess there's like quite a lot of challenges. So yeah, there you have it. Let's take a look at the questions now. You should see the, see the questions here. Daniel says that he owes me $5, but cannot donate through YouTube. You can donate through PayPal. We have it written somewhere. I'm pretty sure we have. But yeah, you can donate with PayPal. Anyway. Yeah, it was guessing. Cool. You can use statistics endpoints in Wireshark. True. Yeah, the statistics and like the whole analysis part is pretty cool in Wireshark as well and pretty useful. So that's a good common gaps. Then we have Gunveil. I know a little bit of assembly, but when I try to do reverse engineering, I keep getting overwhelmed by a lot of things when I see assembly. How can I get into reverse engineering stuffs? Good question. Now, okay, I know I'm a little bit boring with repeating this answer, but if you go to my blog, there's a blog post about reverse engineering. And so you go here and you look for FAQ. And there's like how to learn reverse engineering. Now, I'm not saying to read through all of it, but this is what you want to do. This is the exercise which you want to do, basically. If you are getting overwhelmed, try to transcribing some assembly stuff into a higher level language. Like basically do this exercise, do it multiple times, do it for small functions, do it for large functions, but for only individual functions, not everything, but only individual functions. And after a while, you should stop being overwhelmed with it, because you already transcribed large functions. So why would you be overwhelmed? And you also start to see some patterns on what to focus on. I think that's the only thing I can say, apart from actually keep practicing, keep analyzing code, keep like reading assembly code, and after a while, I'm not saying you will stop getting overwhelmed, but it will become normal for you. You will know that you are entering a sea of assembly, and a lot of it is nothing you need to worry about. You just need to find the proper information in the sea of information which is flooding you. That's normal, that's reverse engineering for you. You have to get used to it, and you have to remember to not get sidetracked by the assembly code, because that's not what you are here for at the end of the day. You want to get some information out of it, and this is what you should focus on. It's kind of a non-answer, but yeah, like this exercise plus experience was basically it. And seriously, do this exercise a lot. It's a really useful exercise. Both for beginners and this is stuff you use, like we did it today already once, right? So Labi writes, how would you today start with security dev? What language would you choose? Yeah, good question. If I would start with programming, right? Python. I would start probably with Python, and then go with JavaScript, and then maybe with C++ or Rust or whatever. That's basically it, but Python is the first language for security. Otherwise, how would I start? Yeah, it's a good question, because at the beginning you have to learn a lot of stuff. there's like a lot of information to gather at the beginning, right? Because you need to, I guess the first step is always to look around, right? Like see what types of stuff people do, and then find one thing or a couple of things which are interesting most for you and start going deep there and learn everything on the way. So yeah, I know it's kind of non-answer, but it's a really broad question. Just so you know, this challenge is so stupid. It took me a while to get it. Yeah, I understand your sentiment. Yeah, okay, then I see what the web told me to look for the start and end. I don't look at the chat or questions during attempting to solve unless I'm super stuck, so I did miss the tip. Yes, this one from Gaps we did see about, I did mention it about following UDP streams. I didn't know that is actually a thing. Okay. Yeah, sometimes you need to brute force the flag. Yeah, sometimes you need to like guess part of a flag. I think I already told you the story, right? Like on some finals, we basically had like, I don't know, 60 seconds remaining or something like that. Like a minute or 2 minutes or 3 minutes. But like a really small amount of time, and we had a brute force running, which gave another letter of a flag every 30 seconds or so, and we were still missing part of a flag, and we just guessed the remaining part of a flag. So sometimes you have to be good at guessing too. Okay, cool. That's it for today, folks. Thank you to KrzaQ for being my moderator today for most of the stream, and to Foxtrot Charlie for being my moderator today through the rest of the stream. And yeah, I'm going to actually do the next part next week. If you understand Polish, there is not going to be a live stream tomorrow, because I thought I could do it, but I'm actually out tomorrow. So next week as well. And yeah, and the English is going to be picoCTF again, and in Polish I have no idea yet. So that's it. Thank you. Happy hacking, folks. Thank you to my moderators again, and see you next time. I'm going to leave you with some music, so yeah, good luck and have fun. Bye bye.